In this session, we will look at a couple of instruments in the cockpit, the turn indicator and the directional indicator. We will illustrate how these instruments utilize gyroscopic properties for their indications. Now we will look closely at the gyroscope. We can see the rotor in the middle, which is a spinning mass that gives us our gyroscopic properties. The outer and inner gimbals enable the rotor to align itself freely in space. The two main properties of gyroscopes are rigidity and precession. First, I will illustrate the property of rigidity. This is where the spinning rotor remains aligned in space. As you can see, now I am rotating the outer gimbal. The property of rigidity is keeping the axis of the rotor in the same alignment in space no matter how I turn the gimbal. We can see this property in the directional gyro. First, I cage the gyro by pushing the heading set knob. As you can see, this has aligned the rotor with the horizontal plane of the aircraft. As I rotate the instrument, the rotor is remaining aligned in space, rotating the outer gimbal that turns the compass card via a gear. If the gyroscope in the instrument has not been aligned properly, it may topple in certain flight attitudes. In this case, the rotor is almost vertical, and because of the instrument design, this can cause erroneous and sharp readings until the rotor has been realigned. Now we'll look at the indications during a turn and the turning errors induced by the tilting of the rotor axis. In a steady yawing turn, the instrument indicates normal. Once we introduce some bank, the now tilted rotor causes readings that show varying rates of turn even though the turn rate is constant. The card speeds up and slows down. As the bankers increase, the gyro topples, as seen by the sudden reversal of the card. The second property of gyroscopes is precession. If we apply a torque against the rotor axis, this torque manifests itself as a torque 90 degrees later in the plane of rotation. The turn indicator uses this property to indicate the rate of turn. Yaw in the aircraft applies a torque to the spinning rotor in the instrument. The precession in the instrument is indicated as the rate of turn. Roll and pitch have no effect on the turn indicator.